Smath here. Time to talk about bonding. Now, this is our first in a series. We're going to talk about this one. We're going to talk about bond types. There are three types of bonds that we're primarily concerned with. The first is a metallic bond. These only occur in pure metal samples. So a sample, just a chunk of aluminum, that would have metallic bonds in it. But if it's a metal with anything else, it won't have a metallic bond. These are described as having delocalized electrons. The electrons are free to move throughout the entire crystal. We're not going to worry too much about those in this video. In this video, we're more concerned about whether a bond is covalent or ionic. Covalent bonds share electrons between two atoms, only two atoms. So we could have a nonpolar covalent bond where they're going to share that electron equally, or we could have a polar bond where they're going to share a pair of electrons unequally. Those are covalent, very common. Then the last one we have are ionic bonds. Ionic bonds are where there's a true transfer of electrons throughout, from a metal to a nonmetal. The metals give up an electron, the nonmetal accepts an electron. This is complete transfer, and those happen. So how do we determine what type of bond it is? Well, we need to have this electronegativity scale. These values are given, they're always provided, and these are the general attraction that an atom has for an electron. That's what electronegativity is. We go from values being very low of 0.7 down in the lower left-hand corner, all the way up to values being very high, a 4.0 attraction being very high. Then, to determine our bond type, we're going to take the electronegativity difference of these two values and put that on this scale. So the largest attraction we could have is 0.7 and 4.0, so the top end of our scale is 3,3. The smallest difference we could have is if we had one of our diatomics bonding with itself, O2 or H2. It would have an electronegativity difference of 0. So compounds that have an electronegativity difference between 0 and 0.4 are nonpolar, between 0.4 and 1.7 are polar, and between 1.7 and 3.3, those are going to be considered ionic bonds. I have three examples for you down here at the bottom. Let's look at CH4, a methane molecule. I know that carbon is attracted to hydrogen. I came over to my values. I subtract the larger from the smaller. My electronegativity difference is 0.4. If I'm on the line, I'm going to round up. That means I have a polar bond between carbon and hydrogens. In this case, there are 4 polar bonds between carbon and each one of those hydrogens. Just because there's a 4 there, don't multiply these values by anything. Use them as they are written. Now, let's look at our second example. Now we've got sodium with a value of 0.9 and fluorine with a value of 4.0. That electronegativity difference is 3,1. That's way down here. That's a very ionic bond. And that's going to change how the characteristics of this molecule behave. We're not going to get into that now. Right now we're just trying to do bond types. Now, here's a little more complicated molecule, magnesium phosphate. This has a polyatomic ion in it. So what do I need to do? Well, I know magnesium is attracted to PO4. I've got to know my polyatomic ions here. And then this problem is really easy because magnesium is going to be attracted to the ion and form an ionic bond. And within every polyatomic ion, there are polar covalent bonds. So within magnesium phosphate, there are 2 kinds of bonds. That's perfectly okay. That can happen. So what we need to do to figure out bond type is see what's attached to what in a molecule, and then use our electronegativity differences, or use our polyatomic ions that we've learned, put them on this scale, and we can easily determine bond type. Bond type is going to help us lead to the molecule type and what shape it is and how it's going to behave in a chemical reaction. So this is the beginning of bonding. This is how you determine bond types. I'm Smath. I hope this video helped you.